Okay, number 6 from 2012. And as far as series questions go, this one's fairly straightforward. We have this series for G, um, and they want you to use the ratio test to find the interval of convergence, which means we need to go on and test the endpoints. And so that would be, let's see, so we'll have to set up our limit. N goes to infinity of -1, n plus 1 times x. 2 times n plus 1 will be 2n plus 2. Add the extra 1, you have 2n plus 3 over, and this will be 2n plus 5 in the denominator, times the reciprocal of the original, 2n plus 3 over -1 to the n, x to the 2n plus 1. Don't forget your absolute values. And then we start reducing wherever we can. We'll see here. There are 2 more x's on top than on bottom, so I'll just change that to an x squared. I have 1 more -1 on top than I have on bottom, but that really isn't going to matter because the absolute value will get rid of the -1 and make it positive. So now I have limit as n goes to infinity of, actually the absolute values are unneeded now because -1, the absolute value of that is +1. Absolute value of x squared is x squared, and 2n plus 3 and 2n plus 5 are positive anyway. And so now my limit is a function of n. My degree of n is equal on top and bottom, so we'll divide their coefficients, which I guess technically are 2x squared and 2, but the 2's will cancel. And your ratio test shows convergence when the answer to the limit is less than 1, and x squared will be less than 1 when x is between -1 and 1. So our radius of convergence is going to be 1. However, the interval, we need to test the endpoints. So now I'm going to test x equals 1. And when I do that, I would have the series from 0 to infinity. So if I plug in 1 for x, I'll have -1 to the n over 2n plus 3. And that will converge by the alternating series test. So I would point out that the limit as n goes to infinity of 1 over 2n plus 3 does equal 0. And you want to show that the n plus first term is less than the nth term. And so that would be 1 over 2 times n plus 1 plus 3. Is that less than 1 over 2n plus 3? And it is, because the denominator is larger. Therefore, we converge by the alternating series test. So converge for x equals 1. Now I need to test x equals -1. And so that will give me the series of -1 to the n times -1 to the 2n plus 1 over 2n plus 3. That would be -1 to the 3n plus 1. And now let's see what happens to that -1. Will this series alternate like it did for x equals 1, or will this always be an odd or always be an even exponent? Now let's see. So if I plug in 1, that'll be -1 to the 4th. If I plug in 2, that'll be -1 to the 7th. That's odd. If I plug in 3, that'd be -1 to the 10th. That's an even exponent. If I plug in 4, -1 to the 13th. So this will alternate. So this does alternate. And we have already shown that the alternating series of 1 over 2n plus 3 does converge in the first part. That converges. Therefore, my interval of convergence includes both endpoints. So that would be -1 to 1. And that's going to be the hardest question for this. Usually the harder ones show up at part B or C. Or maybe I should say that's the most labor intensive. That was more work than we're going to have to do for any of the other ones. Okay, so they tell you the Maclaurin series for G evaluated at 1/2 is an alternating series whose terms decrease in absolute value to 0. So basically they're telling you this is obviously they're telling you it's a convergent alternating series. The approximation for g of 1/2 using the first two non-zero terms is 17/20 show that this differs from the actual value by less than 1/200. So we want to show that the magnitude of the error when plugging 1/2 in is less than 1/200. And for an alternating series test, that is really easy. We're going to plug in 1/2 for all of my x's. So I have 1/2 over 3 minus 1/2 cubed over 5 plus 1/2 to the 5th over 7. And in an alternating convergent series, which they have laid out the groundwork for you, your error is less than the first omitted term. And I think I'm going to put that in writing. Typically, when you're using the error bound for an alternating series, you need to include this in your explanation. You need to actually write the series is an alternating series whose terms decrease in absolute value to 0. Therefore, the error is less than the first omitted term. However, since they put that sentence in the question, they're saving you from having to do that. So all we have to do is say that the error is less than the first omitted term, which is 1/2 to the 5th over 7, and we just have to clean that up. So that'd be 1 over 2 to the 5th is 32 times 7 is, 7 times 30 is 210, and so 7 times 32 is definitely going to be something larger than 200, and the question was to show that, just show that there is less than 1/200. We don't have to find the actual value of 1/32 times 7, and my times looks an awful lot like a decimal, so I'm going to change that into parentheses so the reader cannot possibly misread that. And then C is going to be fairly straightforward. Write the first three non-zero terms and the general term for G prime. We're simply going to do the derivatives of the first three terms. So G prime of x, derivative of x over 3, minus the derivative of x cubed over 5, plus the derivative of x to the 5th over 7. And then for the general term, we'll do the derivative of that. Now remember, the series, we're doing the derivative of with respect to x, so the n's are constants this time. So -1 to the n will bring down the 2n plus 1. And we'll subtract that from the x. So x to the, whoa, what am I doing there? So 2n plus 1. X to the 2n, if you subtract 1, that'll just be x to the 2n all over 2n plus 3. Plus ... and there are your first three terms and the general term. So I think this question got progressively easier, which is atypical for a free response question.